Hi, I'm Stan Oda, the product manager for the ShockLine family of VNAs from Anritsu. Today I'd like to speak to you about a few key automotive applications that the ShockLine family of VNAs target both inside and outside of the car.
Here are some sample automotive applications that ShockLine VNAs target. The MS46121B and MS46131A one-port VNAs are well suited for testing return loss on all the different kinds of antennas available on today's automobiles. These VNAs can also enable material measurements, which can be used to test for such items as surface defects on the outside or unwanted moisture on the inside of the car. The MS46522B E-band VNA is an excellent choice for testing radar components and antennas used in ADAS systems. The VNA is also suited to measure material characteristics of the bumpers or emblems in front of the radar transmitters to make sure they are RF transparent to the radar signals. The wideband 500 series ShockLine VNAs can be used for characterizing high-speed interconnects such as Ethernet or Thunderbolt used in the ADAS and other systems in the car. The ME7868A distributed two-port VNA brings unique capabilities to testing over-the-air characteristics of larger vehicles like automobiles. Let's take a further look at each of these applications. Here are the one-port ShockLine VNA models. The MS46121B is a 6 GHz one-port VNA that is well suited for testing cellular, Wi-Fi, and 5G FR1 antennas in the car. These VNAs are small palm-sized units that are easy to connect directly to the DUT. They can also be used to check RF cable runs as well as measuring material characteristics like moisture in the automobile. The MS46131A is the highest frequency one-port VNA available on the market today, enabling 5G FR2, 28 and 39 GHz antenna testing in the car. It's a compact and portable VNA which allows for direct connection to the device or antenna under test. The 43.5 GHz measurement capability also results in better resolution for fault coverage in cable and material testing. Both one-port VNAs offer options for insertion loss measurements. The MS46121B has a scalar-only option, and the MS46131A has a very unique vector option, which will be discussed further in a bit. The MS46522B E-band VNA is a self-contained banded two-port VNA covering the 55 to 92 GHz extended E-band frequency range, perfect for radar applications. As you can see, it is a unique tethered configuration which connects the E-band modules to the base chassis, requiring no additional cabling or setup by the user in order to make measurements. It comes in two different tether configurations, a 1 meter and a 5 meter model. The port modules are small and compact, making integration into test setups much easier than competitive multiplier modules. The VNA is well suited for measuring automotive radar antennas used in ADAS systems. In addition, the E-band models can be used to characterize the material properties of the auto emblems and bumpers that are used as protective radomes on cars to make sure they do not block any of the RF signals to and from the radar systems. The different tether lengths help address the different size requirements in each of these types of automotive applications. The wideband 500 series performance VNAs come in 2 and 4-port models and are excellent VNAs to test high-speed interconnects used in ADAS and other systems in an automobile. Offering up to 43.5 GHz test coverage in a space-efficient and robust package, these VNAs can measure return loss, mode conversion, and impedance on standard interconnects like Ethernet or Thunderbolt. An example of this is pictured on the right, with a block diagram of the setup and some measurement results of a Thunderbolt return loss test. The newest ShockLine VNA is the ME7868A distributed two-port VNA. It uses two synchronized MS46131A one-port VNAs as portable VNA ports to create a fully reversing vector two-port VNA. With patented Anritsu technology, the MS46131A can be synchronized while located 100 plus meters apart, enabling direct connection to large-scale DUTs or to widely separated test antennas. This eliminates long test port cables, which delivers better measurement dynamic range and stability for S-parameter measurements, and simplifies and lowers the cost of test setups for many longer distance applications. The ME7868A Two Port VNA's distributed port architecture offers unique advantages for applications like automotive RF shielding and propagation testing or auto antenna pattern measurements. An example use case is shown in the simplified block diagram on the right, where the remote ports of the ME7868A are directly connected to the source antenna and antenna under test, eliminating the need for long interface cabling or other complex hardware infrastructure.
For more information on any of the ShockLine vector network analyzers mentioned today, or on any other Anritsu instrument involved in automotive testing, please see our website at anritsu.com. Thanks for listening.